In mathematics education, most students are going to be introduced to the formulas for calculating the circumference and the area of a circle. For many students, this is their first formal introduction to pi. And when I was at school many years ago, all that I was told was that it was a constant value of 3.1415 and so on, and that was about it. Move along, nothing else to see here. So what I want to do in this video is provide a bit of context to pi. To begin with, we can easily find the value for pi on a calculator or mobile phone by pressing the symbol for pi. In a previous video I mentioned that pi is an irrational number, which means that the decimal goes on and on and on with no repeating pattern. So what is the definition of pi? Well, to understand that, we need to look at this formula here. The circumference of a circle is equal to pi multiplied by the diameter of the circle. We can rearrange this formula by dividing through by the diameter so that we have pi is equal to the circumference of a circle divided by its diameter. And there's our definition. Pi is defined as the ratio of the circumference of any circle to its diameter, and that the value will always be 3.14159 and so on. And because pi will always be the same amount, it is therefore a constant. Its value will never change. Why is this? Well, all circles have a special property. They are all similar. That is, regardless of the size of the circle, they have the same shape. So regardless of the diameter of any circle, if you find the circumference of that circle and then divide it by its diameter, you will obtain the value for pi. You can find an approximation for pi by taking any circular object, measuring its diameter, and then using a piece of string, measure its circumference. You then divide the circumference by the diameter, and there's your approximation. Alternatively, you can find an approximation for pi by drawing a circle of known diameter and then draw regular polygons of increasing sides within the circle so that the vertices of those polygons touch the edge of the circle. By calculating the perimeter of the shape and dividing it by the diameter of the circle, this will also produce an approximation for pi. And of course, the greater the number of sides of the regular polygon, the better the approximation. And it was this method of exhaustion that was used by Archimedes at around 250 BC and was one of the first to explore pi in any great detail. He drew regular polyhedra outside and inside of a circle to create upper and lower limits for pi. He estimated pi by using a polygon of 96 sides, producing upper and lower limits of 22/7 and 223/71, giving a decimal approximation of 3.1418. The work of Archimedes remains significant today, as his approximation of 22/7 is still commonly used. Archimedes was one of many mathematicians to explore pi. Some of the earliest mathematical texts date back as far as 1650 BC and shows pi as an estimate of 256/81, or 3.16049. Subsequently, over the years, various mathematicians have produced their own approximations. Pi is also implied in the Bible, where reference is made to the casting of a great bowl 10 cubits wide and a circumference of 30 cubits. And of course 30 divided by 10 is 3. The symbol for pi was first introduced by the Welsh mathematician William Jones in 1706, although the symbol itself had been used in other contexts. For example, the ancient Greeks used this symbol to mean the number 80. With pi being an irrational number, This means that either the circumference of a circle or its diameter will also be irrational. So for calculations involving circles, we are going to end up with issues of accuracy as rounding errors will be introduced. But how accurate do we need to be when using pi? Well, let's consider NASA. No doubt, accuracy is important here. I did a bit of exploring on this and found this interview with the director and chief engineer for NASA's Dawn mission, Marc Rayman. It can be found on the Jet Propulsion Laboratory website. He explains the accuracy that can be achieved when using pi to just 15 decimal places. The planet Earth is 7,926 miles in diameter at the equator. The circumference then is 24,900 miles. That's how far you would have to travel if you circumnavigated the globe. And don't worry about hills, valleys, obstacles like buildings, waves on the ocean, etc. How far off would your odometer be if you used the limited version of pi to 15 decimal places? It would be off by the size of a molecule. And to calculate the circumference of a circle with the radius of 46 billion light years, that's the radius of the universe, by using pi to just 39 decimal places, it would produce a value to within the accuracy of a hydrogen atom. As mentioned at the beginning of the video, the two formulae you will be introduced to will be the circumference of a circle, which is pi multiplied by the diameter of the circle, and the area of a circle, which is equal to pi multiplied by the radius of the circle squared. Since pi is irrational, it is therefore advisable, when performing calculations using pi, to be comfortable with rounding to a certain number of decimal places, as you will end up with an answer that will be more than likely irrational. I have covered rounding in a previous video, links in the description below. So for example, what is the circumference of a circle with a diameter of 2 centimeters? Give your answer to 2 decimal places. Well, the circumference is pi multiplied by 2, which is equal to 6.283185 and so on. So the answer would be 6.28 centimeters to 2 decimal places. What is the area of a circle with a radius of 5 meters? Give your answer to 3 decimal places. Well, the area is equal to pi multiplied by 5 squared, which is equal to pi multiplied by 25, and this gives an answer of 78.53981 and so on, and this is equal to 78.540 meters squared to 3 decimal places. So there's a brief look at pi to provide a bit of context when you are working with circles. I hope you found the video helpful. Don't forget to like and subscribe, and thank you for watching.